Morning, guys. So today we'll be dealing with the portion from where we stopped in our live class. I hope during live class we have completed till average velocity, because today we'll be completing instantaneous velocity and instantaneous acceleration, etc. Small topics as we have discussed during the live class. Okay, so before moving to the bigger topics, I hope you guys know what is differentiation. It's a math topic, guys. Differentiation and integration. Because from here, differentiation integration will be lot done during physics. I'm not going to take the entire thing as in the math point of view, only the portions which is required for our physics. That much portion will be taken. Okay, so before going to the instantaneous velocity, blah blah blah, we'll first go for differentiation, the concept of differentiation. Okay, that means I will explain it to using graph, guys. Okay, suppose you have a graphical representation like this. I hope you know what is x-axis and y-axis. So this is your xy graph. X is in below position and y is above. So you have an xy graph, and I'm drawing this x. I will say this is your 0 point, right? You're drawing, all right. Let's say I'm going to take two positions, guys. This is our x1, this is x2. Its respective y value is, this is y1 and this is y2. This much respective value we are doing, right? This and all you have learned in your ninth, right? So let's say this angle is theta, right? So this angle also will be theta, right? Any line which I am drawing here also theta, right? This and all you know, right? So okay, let's just consider this angle theta, right? So what will be tan theta, right? So that means I have to consider a triangle. Let's say this triangle, I'm going to consider this small triangle, right? So this angle is also theta, right? So this point will be what? Y2, right? This is y1. So this is y1, right? This is y2, this is y1. So this much length is y2 minus y1. Right? Similarly, this much, that is a base of this triangle, is x2 minus x1 from the figure itself. Very easy to understand, right? So tan theta, right? Tan theta is what? The opposite side by base. So it will be y2 minus y1, right? That is tan theta divided by x2 minus x1. Please register it, guys. Or I can write it as delta y, right? Change in the y, or change in y position divided by change in x position, right? Very easy. This is something which you have learned even in the ninth class. Now I'm going to make it a little bit more complicated. Same xy graph, guys. This is x, this is y. I'm plotting it like this, right? Now it is not a straight line, there is a curve, right? So initially we just found what is slope, right? Tan theta, you remember the tan theta was the slope of what? The xy graph initially. So this is theta, right? So this gives you the slope. So tan theta was the slope, right? So here, can I take theta, fix it? How can I take theta? Suppose this is a point. How can I find an angle for it? I will draw a tangent. So this is my theta. Well and good. So but if I consider a point like this and I draw a tangent, this angle will be another angle theta 1, right? Another angle, right? Similarly, if I consider a point like this, then another tangent, so this will be theta 2, right? So the angle changes on. So initial case, in earlier case when I consider, all the thetas were same, right? The angles were same, but here the angle is different. That means I can change the slope here, right? So this figure, there is a change in slope continuously. There is no change in slope here. Slope is fixed. Right? I hope you understood the scenario. So how will we find the slope? Right? So that means I'm going to see, the problem was that when I drew a figure like this, right, I consider 2 points like this, right? This is x2, y2, right? This point will be x1, y1, right? The corresponding x1, corresponding y1, this is corresponding y2, corresponding x2, right? And in this point, this was the theta, right? And for this one, the theta will be like this, right? So the problem came when the distance was very different, right? Right, so this is theta 1, this is theta 2, very, very different angles. So what should we do? So the problem was rectified. Suppose if I bring these 2 points very close to each other, that means, see, sorry guys, right, this is my graph, right, same slope I am having. But if this is my x2, y2, right, I will consider x1, y1 very close to it. Right, now when I draw a slope, right, or tangent, this tangent is touching both x1 and y1, x2 and y2, right? Initially what was the problem? There was point difference. So if I draw a slope like this, right, it will be cutting like this, right? It will cut the entire wire, right? So that has been rectified now. Now I consider 2 points x1 and y1, x2, y2 in such a way that they are very close to each other. So that now when I consider this tangent, that tangent is touching both the points. That means now the angle theta is fixed. Clear? The scenario you have understood? Right? Right? Now I am going to draw this figure, this one, a little bit larger. Right? So this is my tangent. Right? Now this tangent, this point is x2, y2, this enlarged one, okay? This is x1, y1. Right? So this is my theta. Right? So this is what? y2 minus y1, and this is x2 minus x1. Just like the previous case. You just enlarge this much portion here. Clear? Right? Or I can write this entire scenario like this. In place of y2 minus y1, I'm going to write it as dy, small length. That is the meaning. Very, very small length. Why? This y2 minus y1, right, was very small, that its y value is not 0, but is quite close to 0. Similarly, x2 minus x1 is very small such that its value is quite close to, that is, it is trying to become 0, but it is not 0. That much small it is. Right? So that terms which is not actually equal to 0 but a very small value can be represented by dy. For y coordinate, for x coordinate it will be dx. Clear? So this is theta, right? So tan theta now is what? Dy by dx. Right? So what is tan theta? For any graph, tan theta is the slope. Right? So slope of a graph can be written as actually dy by dx. Right? Clear? So slope of an, this is y, this is x graph, right? So slope of an xy graph is dy by dx. Keep it in your mind, right? And this dy by dx is known as differential term. Clear? Right? Right. Now I will give you some formulas, or just one formula because that is only needed. Right. So d by dx of x raised to n is equal to n into x raised to n minus 1. I hope you didn't know or didn't understand what it is. That is, if you are having a function, right, x raised to n function which is to be differentiated with s itself, the formula is this one. You have to by heart it. There is no other way. Right? You have to by heart it. I will tell you 1 or 2 problems we will do so that it will come off as soon as you read the question. Right? By heart it this equation, write it down. Even if you are learning biology, this is very easy even for biology students, guys. Okay? I hope you have written in in your notebook and by hearted it. So let's do a problem, guys. Suppose you are given a function x is equal to 3t squared plus 2t. Right, this is your function and you are finding dx by dt. Very simple. You are finding dx by dt. Remember, you have function dx raised to n dx. That means here having both the functions same, right, xx, but here function is different, right? So how would you do it? How to do this one, right? So that means you are in place of x, you are going to write 3t square plus 2t, right? Now the numerator section and denominator section is same, right? Now I'm going to split it, guys, just like mathematic function. D by dt 3t squared plus d by dt bracket, that is 2t. That is, you are giving this d by dt to both the terms. Simple, right? Now we'll start by rubbing stop. Right, after this function, what should we do? I'm writing, guys, right? So d by dt of this function, 3 is a constant value, right? Can I make it into a smaller function? No. So this formula, constant terms cannot be differentiated. Differentiated means you can you make it in a simpler, smaller value section with respect to time? No. 3 doesn't depend upon time, right? So 3 goes out. So it is dt squared by dt. Similarly, 2 is a constant value, so 2 is brought out, so it will be dt by dt, right? So what is this expression? It is same as this one. What was dx raised to n dx? It was n into x raised to n minus 1, right? So what is n in this problem? N is 2, so it is 3. So in place of n, I am going to write it as 2. In place of x, it is t. And in place of n minus 1, it is 2 minus 1, that is 1, plus what is dt by dt? 1, right? So you'll get the value of 6t plus 2. That is your answer, right? So differentiation of what? 3t squared plus 2t is 6t plus 2. Do you guys find it difficult? I don't think it is difficult. We'll do a similar problem again. Suppose the x function is, let's say, 6t cube plus 4t squared plus 3t plus 2. Right? Pause the videos, try to do it by yourself, guys. And your question is, what is dx by dt? So d by dt, in place of x, write the entire function 6t cube plus 4t squared plus 3t plus 2. Right? Now give d by dt for all the functions. See, the first time you are writing, right? So it's okay if you write the entire thing. But as you do a lot of questions, this and all will come to your mind as it is. Right? Plus d by dt of 3t plus d by dt of 2. Right? Here see, guys, this d by dt of 2 is a constant term. There is no t term with 2. So nothing to be differentiated here because there is nothing to be with respect to t. So constant differentiated term, any number, right, without any t or any constant term, without any function, right? This 2 doesn't have any other, you say t, a, b or something like that. It doesn't have t along with it. That term is to be taken value as 0, right? That means this constant value can never differentiate it further. It's a constant. See, when I bring this one, d by dt, right, let's say d by dt, 2 goes out. There is nothing to be differentiated here. There is 1. And differentiation of 1 is 0. Clear? Keep it that in mind. Right? Now let's move on with our problem. Right? So this term goes off. So let's say with this one. Right? N into x raised to n minus 1. Right? So what is n here? 3. X raised to n minus 1. Here x is t. N minus 1 is 3 minus 1, that is 2. Plus 4, that is a constant term. I'll bring it outside. Oh, so there is a sixth constant which I have not put outside. The 6 was outside into d by dt of t cube. And t cube is 3n x raised to n minus 1, right? 6 into 3, right? Plus, here 4 is a constant term, so 4 is brought outside, into d by dt of t square. So n into 2 into x raised to t raised to n minus 1 is 2 minus 1, that is 1. Here 3 is brought outside, dt by dt is 1, so there is just 3. Right? So the end result will have what value? Tell me. It is 18 t squared plus 8t plus 3. That is your final answer. See guys, first time you are guys to doing it, of course you will be finding it difficult, but take your time, do the problems gradually. It will come as soon as you do a lot of questions. Now it will be easy. Okay, now let's move on to our basic section, why we guys are learning this tedious stuff. Okay, so that is our topic, which is instantaneous velocity. Instantaneous velocity. What do you mean by instantaneous velocity? That is a velocity which you calculate at one instant, like this, right? Velocity at an instant. Suppose, see, I was walking to a school, right? And while I was going to school, I found that I'm late, so I will gradually increase my speed, right? So all the time interval, initially suppose at 10 I was having say 3 meter per second, later at 10.5 I increased to 3.2, like that I'm gradually increase my speed, right? So in between at any time, let's say at 10.2, right, I looked at my watch, right, at 10.2, right? If it had been a cycle or a car, it's very easy to say. Suppose, let's move on with the car. Say, suppose I was traveling in a car, right, and I found I was very late to school, and I increased the speed at 10.2. When I looked at the speedometer, I saw a speed, right, let's say 60 meter per second, right? At 10.2, when I looked at the speedometer of my car, I looked at and found it as 60 meter per second. That means this is the velocity at that instant, and that 60 meter per second is my instantaneous velocity, right? That means the time is very short, right? That is like this, right? So then on one clap second, right? So that time interval is very small, right? That means when you consider the velocity, now see, listen, now here our differentiation is coming, right? That means the time interval delta t is very small, that it is reaching the value of 0, not exactly 0, but very small, right? So this small values we considered as how much time interval? dt, small time interval. So v instantaneous, what is the velocity's basic equation? This distance by time, right? So instantaneous velocity, in place of displacement I have write small distance by small time interval, right? This is my instantaneous velocity, ds by dt. Clear? Right. So this I just told you, dy by dx, remember, gives you the slope of xy graph. Remember? Right. So dy by dx gives you the slope of xy graph. That means ds by dt will give you the slope of what? St graph. See, just replace the words. Dy by dx gives you the slope of xy graph. It means ds by dt will give you the slope of st graph. So what is ds by dt? That is your velocity, right? So this is a very important thing, guys. So slope of the st graph gives you velocity. Very important point, right? Slope of an st, that is displacement time graph, slope gives you velocity, right? Right. Now say you are having a function s is equal to t squared. This is how the problems will be there. Okay, so that the displacement is a function of time like this, right? So I will make a column, right? I will make a column like this, so like this, right? Because I want, this is how you plot, right? So this is my s, this is for t, right? When t is equal to 0, s is 0, put the values here. When t is 1, s is 1. When t is 2, s is 4. When t is 3, s is 9, right? Just put the values. Now I'm going to plot these values in a graph, right? This is my, let's say this is t and this is s, right? So put the values here. Initially it's 0, then when t is 1, s is 1, then 2, it goes on, 3 goes on, and I plot the graph. See, when I'm drawing it doesn't look proper, it is curvy, right? When you draw it, it will be like this, right? Because the time duration is less but the displacement is increasing in a fast pace. See, first the difference was only 1, then it became 3, then it became 5, right? Very high change in displacement. That means the velocity is varying. Clear? So we just told what is the slope of ST graph or displacement time graph. It gives you velocity. So in order to know the slope, what should we do? At any point, if you want to find the velocity, we have to draw a tangent, and this angle is theta, right? So then you will find what tan theta, right? If you find what is tan theta, you find the slope. So what is the slope of VT graph gives you? You give you the velocity. So very easy. No, it is not easy. It is very tedious job to find theta, etc. Right? So that's why we are taught, or I taught you guys the differentiation. Clear? So s is equal to t square. That's our function. And I taught you velocity. Instantaneous velocity is ds by dt. So we just have to differentiate this term, guys. So what is ds by dt, right? So in place of s, I am writing t square dt, right? So what was the formula? N into x raised to n minus 1. So what is n here? It is 2. So 2. What is x here? T. N minus 1 is 2 minus 1. So 2t. So you will get the velocities equation as 2t. Right? So V is equal to 2t. If the question had been what will be the velocity at 1 second, then you just have to substitute this one in this equation. You will get 2 meter per second. And the question is, suppose the question has been changed from 1 second to say 2 seconds. Right, so that means here you have to replace t with how much? 2. So the answer will be 4 meter per second. Right, now the question, if it had been, time has been changed to say 3 meter per second. Right, so again you just have to replace it, right? So it will be how much? 6 meter per second. Right, just values have been changed, right? So initially you find that the velocity is varying, right? Right, so I hope you understood the instantaneous velocity can be calculated by this simpler method. So which is easy, finding the tan theta graphical method or this one? This one. Initially that will be tough, guys, because this is the first time you are doing the problems like this. Suppose this another part of this question. What is the average velocity between let's say 1 and 3rd second? Between 1 and 3. So what is average velocity, guys? You have even learned in your 9th class. So I hope this much has been covered in your live class, right? So or in 9th class you have done. So total distance or total displacement by total time, right? So what is the total displacement here? Let us say distance at 3rd second, distance at 1 second, divided by the time is what? 3 minus 1 is 2, right? What is distance at 3rd second? How can I know that? S is equal to t square, right? So at 3 seconds, just put the value of 3 here. So it will be 9 minus 1. 1 second, what will be the displacement, right? S t is equal to 1 squared will be 1 divided by 2. 8 by 2 will be 4. So that is the average 4 meter per second. That is the average velocity between the time interval of 1 and 3rd second. Clear? Let's do another problem, guys. See, s is equal to t cube minus 6t square, right? And you are asked what is the velocity, or let's say instantaneous velocity. They might not tell you instantaneous velocity explicitly, but see, what is the velocity at t is equal to 1 second means you are asked at that instant. So that means you are asked instantaneous velocity. So similarly, you are asked what is the time, sorry, what is the velocity at the time when it is 3 second, right? So v instantaneous is what? ds by dt, right? So I have to differentiate t cube minus 6t squared by dt, right? So I'll bring all the d by t terms like this: d by dt, t cube minus t by dt of 6t squared, right? So tell me guys, pause the video and try to do it by yourself, right? So this term, right, just like x raised to n, right, dx raised to n by dx is n into x raised to n minus 1. So n here is 3, so 3, right? X raised to x is t, right? N minus 1 is 3 minus 1, that is 2, minus, there is a constant term here. Constant term cannot be differentiated, it brought out, that is 6. Then it is d into t squared by dt. So again this formula, n becomes what? 2, right? T raised to n minus 1, 1 minus 1, sorry, 2 minus 1, that is 1. So it is 3t squared minus 12t. That is expression for ds by dt, right? So what is ds by dt? It is velocity, instantaneous velocity. V is equal to 3t squared minus 12t, that is expression. So at t is equal to 1 second means just put the value of t as 1. So it will be 3 minus 12, that is minus 9 meter per second. That is the answer for t is equal to 1 second. Similarly, put the value of 3 in the t. So it will be 3 into 3 squared is 9 minus 12 into 3, that is 36. So 27 minus 36 is again minus 9 itself, right? So when t is equal to 1 second, the velocity is minus 9 meter per second. When t is equal to 3 second also, the velocity is minus 9 per second. Now we'll do another question along with it, right? That is the part of the same question, guys. The time taken when the body is at rest. That is when body is at rest. How much is the time taken? So you know what is the relation of at rest? At rest the velocity is 0. So we just found the value, right? So that means velocity is 0 means what is the expression of velocity which we have just found? It is 3t squared minus 12t is equal to 0. So that is 3t squared is equal to 12t. 1t can be cut off. So t is equal to 4 second. Right? So at 4 second, right, the velocity is 0. Velocity is also 0 when the body is starting, right? It is starting. At that point also velocity is 0, and it is said that after some time the velocity is increasing, or what, some according to this equation the velocity has been increasing. But at 4th second again the velocity is dropping to 0. Clear? Very easy if you are not making it tough, right? So I would request you guys to do a lot of problems like this. You guys can write the equation by yourself and try to do the derivation by yourself. Like I will give you the problems as homework so that it will be easy for you guys to practice. Okay.